Welcome to the science of popcorn, why it pops. Have you ever wondered about the magic behind one of the world's most beloved snacks? Today we're diving deep into the fascinating physics and biology that turns a tiny kernel into a fluffy, delicious treat. Get ready to discover the secrets of the pop. Popcorn isn't just a snack, it's a phenomenon. From movie theaters to home kitchens, its unmistakable aroma and satisfying crunch are universally loved. But what exactly makes a humble corn kernel explode into something so delightful? It's a simple pleasure, isn't it? The anticipation of the first pop, the rhythmic dance of the kernels, and then a bowl full of warm, buttery goodness. But beyond the enjoyment, there's a cool scientific story waiting to be told. For centuries, the popping of corn was a mystery. How can a hard, unassuming kernel suddenly burst open and expand so dramatically? It's not just magic, it's pure science at work. To understand the pop, we first need to look at the star of our show, the popcorn kernel itself. Not all corn pops, and that's because popcorn kernels have a unique structure specifically designed for this explosive transformation. A popcorn kernel is a marvel of natural engineering. It consists of a hard outer shell, called the pericarp, or hull. Inside, there's a soft, starchy endosperm, and crucially, a tiny droplet of water trapped within the starch. That tiny bit of water is the secret ingredient. For optimal popping, a popcorn kernel needs to have about 13.5% moisture content. This water is tightly sealed inside the kernel by its strong outer hull. Now, let's turn up the heat. Whether you're using a stovetop, microwave, or air popper, the fundamental principle is the same: heating the kernel to a specific temperature. As the kernel heats up, the water inside begins to warm. Initially, it simply gets hotter, but as the temperature climbs above water's boiling point, something incredible starts to happen. The trapped water turns into superheated steam. Since it can't escape through the strong hull, the pressure inside the kernel builds and builds. It's like a tiny, natural pressure cooker. The pressure continues to rise, reaching critical levels. And then, at just the right moment, comes the satisfying pop. But what exactly is happening during this split second of explosive transformation? When the internal pressure reaches about 135 pounds per square inch, that's roughly 9 times the normal atmospheric pressure, the hull can no longer contain it. The hull ruptures explosively. This sudden release of pressure causes the superheated steam to instantly expand. Simultaneously, the starchy interior rapidly gelatinizes and puffs out. This rapid expansion causes the soft starch to inflate and invert, turning the kernel literally inside out. It cools almost instantly upon contact with the air, solidifying into the familiar fluffy form we all know and love. And there you have it, the perfect piece of popcorn. From a tiny, hard kernel, we get a light, airy, and wonderfully textured snack, all thanks to a precise scientific process. The unique texture of popcorn, its fluffiness and slight crispness, is a direct result of this rapid expansion and cooling. It creates a porous, airy structure that's delightful to eat. So, the next time you enjoy a bowl of popcorn, remember the incredible science behind each and every pop. It's a testament to nature's ingenious design and the simple yet fascinating wonders of everyday physics.